Today we're going to learn how to evaluate large language models in Python using a package called DeepEval. So let us get right into it. Alright, so we're going to learn how to evaluate large language models in Python, how to evaluate the output of large language models in Python using a framework called DeepEval. This is an open source LLM evaluation framework, and it uses LLM as a judge metrics. What this basically means is that we're using LLMs to evaluate LLMs. And this makes, of course, a lot of sense. If I have, for example, here a prompt that says, I don't know, what is 5 divided by 2, maybe written out, divided by 2, question mark, then I can get a number of different responses. Now, of course, if I have something like structured output, I always want to get 2.5. But if I just have an open answer, I can have anything like 2.5. I can have something like the answer is 2.5. I could have something like the result is 2.5. I could say something like 5 divided by 2 is equal to 2.5. There are many ways in which I can represent this answer. I can even write something like 2.5 if I have a reason to do that. And all of these would be technically correct answers, even though they're not the same. And they're definitely not the same as just 2.5. So it's not that easy to evaluate these large language model outputs if we just use some strict metrics, some formula. So what we do is we use LLM as a judge metrics, where other large language models are looking at the outputs of the initial large language model to evaluate it based on some criteria. Now, instead of diving too much into the theory here, we're going to start right away with a practical example. For this, I'm going to go to my coding directory, so in my case tutorial, and here I'm going to create a UV project. Now, you don't have to use UV if you don't want to. You can also just say pip or pip3 install DeepEval if you want to try this, but I'm going to use UV, so I'm going to say UV init and then UV add DeepEval. Now, what you're also going to need is you're going to need an environment file with an OpenAI API key. I'm not going to show how to do that here because the OpenAI API key, you just go to the OpenAI API, you log in, you get the API key, and then you put it into a file called .env. So .env, or in my case now I'm going to type something else just so I can open the file. And here you want to say OpenAI underscore API underscore key is equal to whatever the key is. Then you save that. You save that as .env or .env.local. You can choose one of the two. And then you can use it automatically with DeepEval. It already finds that key and uses it for the evaluation. So let us get started with a very basic example. I'm going to create a file here called test underscore, let's say 1 underscore simple.py. Now, if you want to use DeepEval as a testing framework, if you actually want to run your tests like unit tests, you have to actually call the file test underscore something. If you just want to execute the file with Python, you can just say 1 underscore simple. In this case, I have to say test 1 simple because I'm going to use DeepEval test run, which is a command, and it expects the file to start with test underscore. So what are we going to do here now? We're going to do a simple example. I'm going to say here from DeepEval import assert test. So we're going to assert that the test actually passes. Then I'm going to say from DeepEval.testCase, I'm going to import the LLM. By the way, to have autocompletion, I need to activate my environment for a second here. So I'm going to have the LLM test case and also the LLM test case parameters. And finally, I'm also going to have a metric. And we're going to start with a very basic, simple example here called the GEval metric. So GEval. By the way, if you want to look up anything that I'm not covering in this video, you can go to the documentation here. One thing that you will notice is, for whatever reason, they're very, very, very excited to somehow redirect you to Confident AI. They have it all the time, everywhere. Confident AI, try the platform, go to the platform, go to the platform. Even if you Google, let me show you that. This is actually kind of funny. If you Google DeepEval like this, you're not finding deepeval.com because it tries to redirect you no matter what to Confident AI. I think this is some sort of monetization stuff. There's some service that they're offering. But yeah, if you want to go to the DeepEval doc, you go to deepeval.com and then you go to docs. So here you have, and again, you can see confident AI is being pitched. We're not going to cover confident AI in this video today because, yeah, it's not part of the free open source here. And since this is not a sponsored video, we're not going to cover the paid service. But essentially what you have here is you have a quick introduction, and here you have a basic example, which I'm going to cover here, but I'm not going to go through the doc with you. So I'm going to just build it here, and we're going to discuss the individual lines of code. So we're going to call this function here, this test correctness, or you could also say test accuracy, whatever. And the GEval metric is a very general metric. So it means you can basically make it measure whatever you want it to measure. So I can call this now correctness metric, and I can say this is GEval. And the GEval basically consists of a name. So I can call this, for example, correctness. And the most important part here is the criteria. The criteria is just some text explaining what this metric is about. For example, I can say, check if the actual output is exactly the same as the expected output. That would mean we're only interested in exact matches. If not, return 0, else 1. This is a very basic criteria here for an exact match. And then I can say that the evaluation params are equal to a list. And here I'm going to say LLM test case params, actual output, LLM test case params, expected output. And then we can also define a threshold, which we can set at 0.5. So the value is going to be something between 0 and 1, and it's going to tell us what this metric is on a scale from 0 to 1. So instead of now actually querying large language models, I'm going to show you an example where we actually do that. But for now, I just want to show you hard-coded responses. So we're going to imagine that there's a test case. We're going to create a test case here. I'm going to call this LLM test case. And in here, we're going to say, we want to have an actual output and an expected output. Now, the expected output is always going to be hard-coded, but the actual output will be actually generated by large language models. So we're going to start with an input, and the input will be something like, what is 5 divided by 2? Question mark. Then I can have an expected output. So expected underscore output is equal to 2.5. However, the actual output, let's say is the result is 2.5. Now what I do is I say assert test, and I assert a test case using the correctness metric, which means the correctness metric has to be above 0.5 or above or equal to 0.5 to pass the test case. So let's save this. Let's run DeepEval test run, or was it run test? I'm not sure. Test one simple. I think it's test run. No module named DeepEval metric. Probably it's metrics with S. Let's see, there you go, it's evaluating it, and hopefully it will fail because we said we want to have an exact match. There you go, you can see failed 1. And you can also see here that the actual score was 0. The reasoning is the actual output includes extra text. The result is 2.5, while the expected output is just 2.5. So they are not exactly equal as required by the evaluation steps. So it followed the instructions and it told us that they are not the same. I can change the criteria and I can say, okay, it doesn't have to be the same. Check if the actual output is the same as the expected output. Don't care. Now I don't have the, okay, I'm gonna just omit the prime. Is it called prime? This symbol here, I'm gonna omit it because or actually, let me do this properly. I'm gonna use double quotations here. And we're going to use it. There you go. Don't focus too much on the formatting. If the meaning is the same, that's fine. It just has to be a true answer. So now the result is 2.5, should give us a metric that hopefully passes, or a score that hopefully passes the test. So if I run this now, we get 1.0. The actual output conveys the same meaning as the expected output, providing the correct answer of 2.5. The additional phrase, the result is a minor formatting difference and does not affect correctness. So now you can see, okay, 100%. Now let's do something else. Let's say I try to add this as text. The result is 2.5. This probably will also give us 100%, but you can also get stuff between 0 and 1. You don't have to always get 0 or 1. You can also get 0.78, for example. In this case, we get 1 because it's the exact same thing. Now I could try to do something else. I could try to say, for example, the result is the same as 3, or maybe as 50 divided by 20. That is true, but it doesn't necessarily give us the answer that we're interested in, even though the result is the same. Let's see what we get here as a score. 0.27. There you go. So that is failed because our threshold is 0.5, which of course we can change. But it says here that the actual output does not directly provide the expected numerical answer, but instead restates the division operation. While it implies the correct calculation, it does not explicitly give the required result, which is a shortcoming in conveying the same meaning as the expected output. So as you can see, all of this is done by GPT 4.1. It evaluates with an LLM as a judge. So whatever the LLM says, in our case now the LLM is me, I'm just giving some sample answers. What you would actually do is you would do some LLM prompting here, and you would get the answer from the LLM and automatically evaluate this. But we can also evaluate for a different metric. Let me show you how to do that here with the evaluate function instead of the assert test, just a different way to do it. And also we're going to do it with conversational Eval. So we're going to evaluate the entire conversation. Besides that, here we're going to say conversational test case, turn and turn params. And then we're going to evaluate the conversation in terms of professionalism. So we're going to say professionalism metric is going to be a conversational, no, actually not that. It's going to be a conversational Eval. It's going to be with the name professionalism. We're going to get rid of all of this, and we're going to just say determine whether the assistant answered the questions of the user in a professional and polite manner. These are the instructions. And now we're going to have a conversation. Let's say this is going to be conversation. Example 1 is equal to a conversational test case. In this conversational test case, we're going to have the actual turns. The turns are going to be a list of turns. So turn here is going to be that. The role is going to be user. User is going to ask a question with a content. So content is going to be what is the, or let's do it like this. Is Python an interpreted language? Question mark. And then we can say here, then we can say that we have the assistant. And the assistant is going to say, of course, how could you not know that? And then the user is going to say, what about C++? Question mark. And then the assistant is going to say, damn, you really know nothing. C++ is compiled, man. There you go. So that's going to be the conversation. And now we're going to say evaluate. And we're going to evaluate here the conversation. Or actually, we're going to evaluate. Let me do, actually, to show you that, let me do 2 examples here. And one of them is going to be polite. So we're going to say here, yes, Python is an interpreted interpreted language. And then here we can say no, or not no, we're going to say C++ is a compiled language. And now we're going to evaluate here the test cases are going to be the following: the list of conversation example 1 and conversation example 2. And the metrics that we use are going to be equal to the professionalism metric. That's that. Let's go ahead and run this and see what we get as a result. We can do both in parallel, so both are evaluated in parallel. By the way, of course, this costs your credits. This costs money. Actually, the second one failed too. I'm interested in why. So here we have unprofessional and impolite. Obviously, in here we say... oh, okay. This is a problem. Here we have assistant, not user. But it's cool to see that it actually fails the test if there's a problem. Cool. Here again, by the way, they're trying to plug in the confident AI. This is a bit annoying, but yeah, I guess you want to monetize something like this. Yeah, so what do we have now? One passed, one failed. The first one failed because the responses... actually, this is the one that passed. This is addressing everything in a polite and professional tone, no errors. And here we say the assistant's answers are factually accurate. However, the assistant's tone is unprofessional and impolite, using dismissive and insulting language, which violates the requirements for professionalism and politeness. Cool. So there you go. You can do something like this. You can also do something like maybe more reasonable or more relevant for a practical use case would be something like a conciseness metric, where you say, okay, determine how concise the assistant is. How often does the assistant add stuff that the user didn't ask for? The assistant should answer in a short format. That is something that you can also implement here as a test case. And then we also get to other metrics that we can use in general, but also especially in the context of RAG. So here I have two that I want to show you. We talked about them already in the RAGis video if you watched it. If not, that's not a problem. We're going to import here from DeepEval.metrics the answer relevancy metric and the faithfulness metric. We don't need turns and turn params. We're just going to go with a basic LLM test case here and evaluate. That's fine. And now we're going to see how different metrics can focus on different aspects. So for example, I can define here the metric equal to answer relevancy metric. This is a predefined metric, so we don't provide a prompt. We say the threshold here is 0.5. And we say that we want to include a reason. So we want to know what happened, why the test passed or not, or why the score was given. And this answer relevancy metric is actually defined mathematically. Of course, we still need LLM as a judge, but it's defined mathematically in the following way. It's number of relevant statements divided by number of total, or I should say total number of statements. So, for example, let me show you what this is. Test case is equal to LLM test case. We're going to have an input, and the input is going to be what is the capital of France? Question mark. Now, if the answer is Paris, I have one statement and one relevant statement. So if I say that the actual output is equal to Paris, this one is going to pass with a 100% score because it's first of all true, it's relevant, and it's the only statement. So we have 100% relevant statements. So I can print here, evaluate, or actually I don't have to print, I can say evaluate test cases is equal to test case, and then metrics is equal to metric. And I'm not sure, can I actually run this with Python? Should be possible. Past metrics, of course I want to pass just metric. There you go. And this is going to give me 100% because it's the correct answer. It's the only answer. and there's no statement besides the one that is correct. So I get 100% because the score is because the answer was perfectly relevant and directly addressed the question. Cool. So if I say the capital of France is Paris, that would still be 100%. But now I'm going to add more statements. Maybe I can say even before that, this is a good question. This is a statement that's not relevant. And then I will say, it is one of the most beautiful cities in Europe. You should check it out. So we have 4 statements, one of which is relevant. Now, I'm not sure if it's going to give me the perfect 25% answer, maybe, but it's going to give me something between 0 and 1 that is not 0 or 1. In this case, it gives me, actually it gives me 0. That's interesting. No, actually it gives me 0.25. That's perfect. That's exactly what I wanted. The pass rate is 0, so no test passed, but we get 0.25, saying it's 0.25 because most of the output was irrelevant, including commentary on the question and unrelated suggestions. Okay, so 1/4 of the answer was actually relevant, which is 25%. Cool. Now we can also look at another metric, which is the faithfulness metric. The faithfulness metric basically just means how much do you stick to the context that you retrieve. So for example, I'm going to use the same threshold in reason here. And now we're going to say, what is the capital of France? And the answer is going to be Madrid. However, it's going to be based on context. This is going to be the retrieval context. And the retrieval context is a list of strings, and one of these statements here is going to be the capital of France is Madrid. Now we know that's not true, we know that's a false piece of information, but faithfulness doesn't care about this. Faithfulness defines truth as whatever is retrieved from the context, or as context. So if there's a statement here saying that the capital of France is Madrid, and I'm answering Madrid, that is going to be 100% faithful, because it's based on the truth, which is the context. So here, if I run this, I should get 100%. There you go, passed. And it says, great job, there are no contradictions, so the actual output is fully faithful to the retrieval context. Cool. Now, if I, on the other hand, say it's Paris, that, of course, is true in reality, but it doesn't align with the context, so I'm going to not pass the test, because that is, from the context perspective, a false piece of information. Okay, this is interesting. Actually, this should not pass. It actually passes, maybe because it's the true answer, but it shouldn't pass. So actually, this is incorrect. So maybe we can go and choose a model here, maybe a more intelligent model. So maybe I can say here model is equal to 01, for example. Okay, sorry, it still uses GPT 4.1 because I think I have to specify model not for the test case, but for the metric, like this. Okay, so I can't prevent this from passing. Maybe I could try to force a different output if I explicitly say it is not Paris. Paris is not the capital of France. I don't know. Maybe if I do it like this, we're going to see that it works. Other than that, if it doesn't work, it's just a mistake on the model side, because the faithfulness metric actually should always stick to the context. So it doesn't do that. It says the score is a 100% because there are no contradictions found. The actual output aligns perfectly with retrieval context. This is just not true because we say Madrid and the context here says, we say Paris and the context says it's not Paris. So that's just not correct, classified or not correctly evaluated by the model. But of course, this can happen. Maybe in this case, it happens because Paris is so obviously the capital of France that it just cannot not pass the test. But yeah, the idea of this metric is to allow or to pass if you stick to the context and to reject, to fail if you don't stick to the context, regardless of if the output is actually true or not. Now, let me briefly show you how to work with datasets. For this, we're going to remove these metrics here. We're going to use GEval. I already prepared a metric here, just a simple correctness metric as before. And now we're going to create a dataset, and we're going to do the evaluation on the dataset. So we're going to use this dataset as a ground truth dataset for evaluation, and then we're going to compare it to actual outputs from LLMs. So what I'm going to do here is I'm going to say from DeepEval.dataset, I want to import the evaluation dataset and the golden class. Golden basically for golden rule or ground truth. And here now we're going to say the goldens, these are the true pieces of information. Our ground truth, so to say, is a list of golden objects where we get some input. For example, what is the capital of France, question mark, and then the expected output is equal to Paris. That would be one golden. Another one could be, what is 12 times 3? And the answer here would be 36. All right, so these are two ground truths. We can turn them now into a dataset by saying dataset is equal to evaluation dataset, goldens is equal to goldens. And now we can easily create test cases. Before that though, I'm going to create a function that is going to simulate LLM answer. So it's going to get some inputs, or let's say some prompt, and it's going to return a dictionary, or from a dictionary actually. We're going to say if the input is what is the capital of France? If that is the question, we're going to just return the capital is Paris. And then I'm going to say here, if the question is what is 12 times 3, maybe with a question mark, then this is going to say 36, like this. Yeah, so there you go. And we're gonna return whatever we get when we pass the prompt as a key. Cool. So this is our simulation, and now we can just say for golden in dataset.goldens, dataset.add underscore test case, not test case from CSV, add test case like this. And we're going to add here an LLM test case where we're going to say the input is the golden.input. The expected output is equal to the golden.expected output. And then the actual output is going to be equal to simulate LLM answer on golden.input. And the results are going to be the following. Results is equal to evaluate, or actually we don't need to store the results. We can just do it like this. Evaluate test cases is equal to dataset.test cases, and metrics is going to be equal, in our case, just to the simple correctness metric. And this is of course a minimal example, but you can of course extend this and customize this however you want. We're now going to say again Python 3, and this is going to launch the evaluation. Of course not, because I don't have the LLM test case params anymore. And now it's doing nothing. Oh, sorry, I need to of course use test cases, not a list where I have the test cases, just like this, because that is already a list. And now there you go, evaluating in parallel, and both pass because they're in essence the same answer. Cool. 99% and 92%. That is awesome. All right, so that is basically what I wanted to show you in terms of functionality. Now I also want to show you an actual example. So this example is a very minimal example. We have here a directory with 3 files: ground truth, CSV, invoice3.pdf, and main.py. And basically, if I open the invoice, you will see, of course, on my other screen now, you will see it's a basic invoice I generated with ChatGPT. The interesting thing is we have some invoice number, date, customer, country. We have some amount here, some unit price, and all that. And then we have the total. So what's interesting here and what is going to probably be an issue for the models is this note here: all prices and taxes are in thousands, which means that 100, or here 100, actually means, or in this case 150, actually means 150,000. So I also have the ground truth here, which is a CSV file. This just has the date, the name, and the actual ground truth in thousands here. And then I have this Python application, quite simple. We have a Pydantic model with date, name, total, taxes, country. We have the path to the document, we have the path to the ground truth, and then we extract a text with PDF Plumber. We have an OpenAI client. One time we use 4.0 mini, one time we use 4.0, one time we use 0.3, and then we just ask to fill the model. We ask the model to fill the data model, and then we evaluate here with GEval how correctly the data model is filled. Formatting is irrelevant. The content or truth matters. Divide the number of correctly filled fields by the number of total fields to determine the accuracy. And here use 0.1 for the evaluation. And I have here these three models that I'm evaluating. And basically, if I run this now, of course, I need to install all the packages: PDF Plumber, Pandas, Pydantic, OpenAI, but then this should work. I can enter here invoice 3.pdf and then ground truth.csv. And now you can see these are the predictions, and they don't get it right. So this is what we get from the LLMs, so GPT-4o mini, 4o, and 0.3. And this is what we actually want to get, so they cannot get the numbers right, none of them. And now we're going to get the accuracy metric. Hopefully it's going to be the same for all of them, because otherwise it's a bit inconsistent. But this will also show us that maybe you cannot trust these evaluation metrics all the time. But in this case, it works. 60% of the data is correctly filled. Is this actually correct? So we have 1, 2, 3, 4, 5 fields, and basically 3 out of 5 fields are filled correctly. So 3 out of 5 is 60, of course, and because of that, this is correct. So it did the calculation correctly. Yeah, so you can see it's not always going to be, but this is not about the evaluation. The model is not going to always get the correct answer, and you can evaluate this here with DeepEval. So actually, I use this in one project that I'm working on right now, which is a real project that is in production and is meaningful. Let's say it's not just a hobby project. And I actually use DeepEval in the admin panel, not for the user, but in the admin panel to compare different models. So I want to know for my specific task what model performs best. I don't want to do it manually. I don't want to spend the time looking into all of the fields. So what I do is I compare Claude models, Gemini models, OpenAI models, all these models, local models together, and evaluate them automatically with my custom metrics in DeepEval. This is a pretty cool use case, I think, and yeah, something to look into if you're interested in automatic evaluation of this fuzzy stuff that is the LLM output. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and